So we are now on problem set 7-6. For problems 5-14, calculate, or 5 to 14, calculate the exact value of the inverse function geometrically. Assume that the principal branch in all cases. So principal branch meaning those that were being discussed. So as a guide, the principal branches are here. Okay, for inverse cosine, it should be on the range should be from negative, or I mean from negative pi over 2 to pi over 2, and the domain should be from negative 1 to 1, and so on and so forth. So these should be our guides. Okay, so starting from number 7, sine of the tangent negative 1 of 5 over 12. So what is the principal branch of what do you call this? Tangent. The principal branch is in quadrants. It's in quadrants 1 and 4. So these are the principal branches, as you can see here. Principal branches 1 and 4. So let's take that in mind. Okay, we have here. So let's use the quadrant 1 in this case. And our guide would be SOHCAHTOA. So SOHCAHTOA is important in the analysis of triangle functions. Okay. So in this case, our x counterpart or the u counterpart would be 12, and the x or the y counterpart or v counterpart would be 5. And then we connect from here up to here, and then here, and then we label the axis. This is u, this is v. This is 5, this is 12, so this must be 13. Use the Pythagorean rule to find this side. Okay? And let's say y equals inverse tangent of 5 over 12. That means that tangent y is equal to 5 over 12. So this is actually y. Okay? And we're finding the unknown here is sine of y, because y is equal to this portion here. So if y is equal to this portion, then we're looking for sine y. Okay? And following that premise, our sine y here would be 5 over 13, right? So sine y is equal to 5 over 13. Okay? So the answer is 5 over 13. Now, if you want to check this, then let's check. What is 5 over 12? 5 divided by 12. Make sure that the computation is in regions. And get the inverse tangent. And then get the sine of this. So 0.3846. Okay? That's the numerical computation. So this is 0.3846. Let's go to number 9. Cosine of the inverse sine or the arc sine of negative 8 over 17. So the principal branches of sine is taking back a look at this thing here. It's in quadrant 1 and 4. So we're going to take the principal branch. So it's on quadrant 4. So this is our axis. And this is y-axis, or let's call it like v-axis, and this is u-axis. And our inverse sine is negative, so meaning it's on the fourth quadrant. So it must be here. Okay. Okay. This, of course, is 17. This is negative 8. And to find this, we consider u square plus v square is equal to r square. So that u square is equal to r square minus v square. So u is positive or negative square root of 17 square minus negative 8 square. So this would be u is equal to 17 square minus, is that 8? Okay, minus 64 equals 225, and square root of 225 is 15. So this is 15, and it's negative. Okay, so u is negative 15. Since we have our u now, then let's say y, okay, is equal to the arc sine of negative 8 over 17. So sine y is equal to negative 8 over 17. So this is actually y. And we're actually finding cosine of y. So what is cosine of y? Cosine of y should be equal to, cosine of y is cosine is adjacent over hypotenuse. So our adjacent here is negative 15, and our, how do you call this, our hypotenuse is 17. So our answer is cosine y equals negative 15 over 17. Okay. Okay, I think there's somewhat of a misplacement here. I said it's quadrant 4, but I wrote it in quadrant 3. Okay, so all we need to do is to just reflect this on the quadrant 4. So just reflect it here. Okay, and cosine in quadrant 4 should be positive. That's why it's very important to choose, well, the quadrants. So I don't know what I was thinking, but it should be in quadrant 4, not in quadrant 3. Okay, so I don't know what's happening here. So let's reflect this on quadrant 4, in quadrant 4 instead. So we have this, and here. Anyway, they will have the same magnitude, just that the value would change for cosine. So this will be gone now, as this is not the correct, what do you call this, placement. Okay, never mind, it's a simple mistake. And so in other words, we have to choose the positive instead because it's on quadrant 4. So in this case, we have, again, this is equal to -8, this is 17, and this must be 15. So our cosine, since our sine y is -8 over 17, we're actually looking for a cosine of y, which is equal to 15 over 17. And that's the answer for this problem. So let's go to the other problems. Number 17. Evaluate the function geometrically and set your answer equal to y and plot it together with the original equation. We don't need to plot it. We're just going to find the answer in radical form. So we don't need to do this. Okay, y is equal to cosine of sine -1, or inverse of sine. So in this case, this will be let z is equal to the inverse sine of x. So sine z is equal to x. And the principal branch of the inverse sine of x is in quadrants 1 and 4, as written here. So we have for sine is quadrants 1 and 4. So because our sine z is equal to x, meaning that we have to consider the first quadrant. Okay. And that means that we have to find a triangle or write a triangle in quadrant 1. So this is our triangle, which is found in quadrant 1. Okay, let's label the axes. Our axes are u axis and v axis. So if our sine z is equal to x, then this one is equal to x, I mean z. This will be z. So what we are actually looking for is cosine of z. Sine x, again, from the SOHCAHTOA, would have to consider our opposite and hypotenuse. So in this x thing here, sine z is equal to x, our denominator is 1, so our hypotenuse is 1. And our opposite is x. And we have to find this, and this is of the form of the Pythagorean. So that's u squared plus v squared is equal to r squared. And u squared would be equal to 1 squared minus x squared. So u is positive or negative. Square root of 1 minus x squared. But take note that this is in quadrant 1, so we have to choose the positive part. Okay, therefore our u here will be equal to positive square root of 1 minus x squared. So our cosine z in this case would be equal to the adjacent over the hypotenuse. So if this is our z, then our adjacent is square root of 1 minus x squared. And our hypotenuse is also equal to 1. So our cosine z is equal to square root of 1 minus x squared. And that's our answer. Let's go to number 20. And number 20 is y is equal to cosine of tangent negative 1 of x, or the inverse tangent of x. So this means that if this is our variable here, so let's say this is z, so that is actually cosine z that is missing. And let's say our argument there is z. So let z is tangent negative 1 of x, or the arctan of x. So tangent of z is equal to x. And the principal branch of tangent is in quadrants 1 and 3. So meaning we have to choose quadrant 1 here. And just following the rule, then we could just draw a triangle in quadrant 1. So say like this. And of course our tangent z is x, meaning our opposite is x. And our adjacent is 1, and the hypotenuse of course is x squared plus 1 squared, or 1 plus x squared. So we're looking for cosine z here. So the cosine of z here would be adjacent over the hypotenuse. So in other words, our cosine of z would be equal to 1 over square root of 1 plus x squared. And this is the answer. So this ends our summary with the problem sets given for lesson 7-6. I hope you enjoyed watching and you have your questions answered. And once again, thank you for watching and listening, and have a nice day, everyone. Goodbye.